So our next speaker is Xuebing Zhou. She has a PhD from TU Darmstadt in collaboration with Fraunhofer. After her PhD, she moved to the Huawei Research Lab in Munich, where she is now leading the research in privacy-enhancing technology.
Yeah, thank you. So actually, I'm also a kind of local person. So I started in the Technical University Darmstadt, also did my PhD here. So it's really today an honor for me to come back and give this presentation. Thank you, Professor Sadiki, to inviting me. Okay, so today I will talk about privacy and AI. So actually, the concept of AI was proposed at the beginning of 1950s. However, the real large-scale application of AI application in the business world is started since 2006, because the big company like Facebook, Netflix start to use this AI technology in the business world. And also the success of AI depends on the technology breakthrough of the technology itself, but also the advancing in the computational power and data storage also make the complex AI tasks possible in practice. So nowadays, actually, we are already getting used to the AI application. So for instance, if we are in a new city and we'll use our mobile phones to look at some nice places to see, and our map apps will automatically generate a router for us. And also the news apps we use our smartphone can personalize the newsletter for us and based on our profiles. And also in the future, the cars can be driven autonomously and without any human interactions. And we feel like AI becomes more and more powerful. It actually has a strong impact on our daily life. And therefore, concerns arise like ethics, trustworthiness, fairness, accountability, transparency, etc. And today, I will talk about AI and privacy protection. So first, I want to give some examples. So many of us know that in 2014, that Cambridge Analytica, they harvest more than tens of millions of Facebook user profile data. And they use this profile data for political advertisement and without any user consents. And after this scandal released, and Facebook lost $35 million in the stock market. But actually, data sharing is quite common in the business world. But how to prevent misuse of the data is a really big challenge. And also nowadays, and the smart devices really becomes very intelligent. For instance, if we use a voice assistant like Siri and Alexa, and it's really give us a new kind of human-machine interaction experiences. However, the user may varying. So whether the service provider will record my voice and who has access to my data. So actually, it is well known that service providers do record this data, and they will share this data internally and even with some third-party contractors to annotate this data. So of course, the service provider will need to have this data to improve their AI services. But on the other hand, the user will feel they are spied by these smart devices. And another example I want to show is a project called Megapixels. And the researchers in this project analyzed more than 22 million of facial photos, which is available in 30 public face recognition databases. It's a surprise that 32% of these facial photos was from search engines, and 24% are from flickers. Actually, facial information is a kind of unique biometric data. And the users who upload their facial photos in the internet maybe even don't know that this data will make use to train some AI software, face recognition software. So all these examples, we can even find more to show that there's a really contradictory requirement in the AI business and also the privacy protection. Then how can we protect privacy in practice? So here I want to start from some basic ideas. So firstly, so if a service provider wants to have access to personal data, he needs a legal basis. And all around the world, this more than 80 countries has already privacy protection law. And European region is one of the leading regions worldwide in the data protection. And they published the General Data Protection Regulation in 2006, which becomes enforceable 2 years ago. And normally, the service provider will ensure their legal basis for the to accessing personal data in the privacy policy. You can find a lot of information there. But only have a legal basis is not enough. In principle, the service provider has responsibility to inform the user about how their data will be collected and to which purpose this data will be used, and also leave the user enough choice to make the decision whether they want to share this data with the user or not. But in practice, so the default setting, for instance, if the service provider by default will collect the user, leave the user the choice to opt out of data collection, or by default, first they ask the user consents, will have a big impact on how much data they can have at the end. So therefore, last year, the French Data Protection Authority, CNIL, gave a fine of 50 million euros to a big search engine company. So because they failed to inform the user about their data usage policy, and also by default says that user accept their privacy policy. For instance, but actually, the problem is for all the service provider, how to make a better UI to provide more transparent information to the users and also motivate the user to share more data with them. And these are just some basic concepts. The service provider also needs a lot of countermeasures to ensure the privacy protection in the whole data life cycle, from the data collection, processing, storage to deletion. There are some these 4 very important concepts to protect the privacy. So, for instance, the service provider should only collect those data which is really necessary for their business and not more than that. And also delete this data as long as data is not used anymore. And also has a very strict access control policies, whom has the right to access this personal data. And but today I want to give more detailed information about anonymization, pseudonymization technology. These are very important technology to reduce the privacy risks and also solve the conflict of data protection and AI applications. So anonymization, pseudonymization is a technical term, but it's also well defined in the law. For instance, in GDPR, so the personal data is defined it depends on whether this data can be linked to a natural person or not. And if this data cannot be linked to a natural person in any cases, and this data becomes anonymous. And if this data can still be linked to a personal data, to a natural person with some additional information, and we call it pseudonymous data. And of course, it depends on how many privacy risks you want to have and how much re-identification risks still exist. And we will have different level of data utilities and privacy risks. And here I want to give some detailed introduction on the technologies. In principle, there are 3 classes to make anonymization. So one is data masking, another is equivalent-based anonymization, the third one is differential privacy. So the data masking is a very simple mechanism, still widely used in the business world. For instance, if we want to share the videos collected from connected cars, and we can, for instance, protect the ID of these videos with a hash function. So, but the equivalent class-based anonymization is required that all the records in the database is not unique to a specific person. So at least several persons must share the same attributes. And this technique is still used in the practice to quantifying the identification risk in the practice. And this technology a little bit more mature, so therefore I want to maybe spend more time to introduce the differential privacy. So differential privacy is a very powerful anonymization techniques. So here I would like to start from some basic concepts, so what it is. So firstly, so I want to give an example that the query or attacker maybe can send some queries to a database and ask the average salary. And if there's a new user joined in this database and the attacker asks the same questions, and then combining these two responses from the database, it's suddenly possible to infer the sensitive information. It's really possible to estimate the true salary of the new user in this example. So this just shows that, in principle, in the world of big data and AI, it's very hard to protect privacy. So even we collect or we make use some non-sensitive information, but in combination of other background information, and it is possible to assess the sensitive data. So therefore, in 2006, the professor worked, proposed this concept of differential privacy. And this gives a new way to protect the privacy and also control the privacy risk. So the idea is quite simple. So if you remember the example I given before, so we have maybe two databases, is very close to each other, and they only differed, they're exactly the same, and they only differed in one entries. And then if we want to, for instance, ask the average salary, so before we send the real answer back, we can add some random noise. So this is this random functions k here. And then the answer will not become static. It's like the output of this random function will be have some randomness. And the attacker, when attacker observes this S, and it's hard for him to distinguish whether the S is generated from D1 or D2. So if we look at the figures on the right side and the distribution that D1 produced the S or D2 produced this S should be very close to each other, and their ratio is bounded by e power of epsilon. So it means that if we apply the differential privacy technique, and then its limited power of the attacker can have access to information of specific user. So it's not about, so the attacker, so the system can still process like crowdsourced information, but to access the data about any specific user is not possible anymore. And the how strong the privacy protection it is depends on epsilon. So if we want to have very high privacy protection, and we need to choose very high, we need to choose very small epsilon and add a lot of noise. And it means also at the same time we will reduce our utilities. So here I want to give examples of how can privacy, how can differential privacy solve the problem in artificial intelligence. So for instance, a service provider has a sensitive database collected. He wants to share this data to a machine learning services and to train some model. But since these data are sensitive, so he cannot just send this data directly to the machine learning service provider. So what he can do is he can use an autoencoder. The autoencoder consists of two parts. So one part can project the original features in a low-dimensional space and force these features to be Gaussian distributed. And the other part is the decoder part. Decoder can take the input of Gaussian distribution and then try to reconstruct the data as the same as the input data. So if the model is changed, so we can discard the encoder part and use the decoder. And then the decoder can use any randomly generated Gaussian distributed data and generate some synthetic data. And here, in order to prevent that the autoencoder can by coincidence generate some data looks like the same as the input data, and during the training we need to add differentially private noise. And we also have some experiments. So if we use the original data and the syntactic data and send it to the machine learning model and look at the performance, and in principle, so we find out we can still have a very reasonable utilities. So for instance, if the dimension of the data is not that high, so we can really have very small utility loss. But when the dimension of the features getting larger, so then of course the performance will be lost more in this case. And I also want to show some specific attack on AI. So these are special because it's not existing in other scenario. So assume that we have a trained AI model, and this model may be used like deep learning network, and the model contains a lot of parameter. So it would be not a surprise that this model parameter can remember some information about the training data. So here are the examples that if we have the trained machine learning model, it's possible, for instance, to reconstruct the training data with very high accuracy, and or we can infer like whether a specific user data was used in training data or not. And this is also a very serious privacy attack. So in a lot of scenarios that even we use the machine learning service as a black box, it's possible for the attacker to access the sensitive training data information. But luckily, so in all of these research papers, it's shown that this attack can be prevented by defensive privacy. So this technology, I'm sure, will be like a standard of protection mechanisms for machine learning and AI in the future. And then I also want to show some advanced privacy protection from AI. So AI always has training and inference phases. And if both training and inference bases happen on the cloud, and the user need to share their sensitive information with the service provider. And of course, it's not so good from the privacy point of view. And currently, we have a possibility, for instance, to put the inference phase on the local devices. This means that the whole prediction and the inference happen on the device. There's no interaction with the cloud. And the privacy protection is perfect. But of course, and for this application, we need maybe dedicated hardware to improve the local processing and reduce the power consumption. And also the AI model itself need to be made more compact and to fit to the local devices. But of course, the model use must be well trained. And then this is another problem, it's not solved yet, but luckily we have another solution with filtered learning. Filtered learning is a new trend in the AI training, that instead to collect all the data on the server and train the model on the server, so we can train the model locally and only send the model update to the server. The central server can aggregate the model and generate it, updated model and distribute it to the client, and the client can repeat the same procedures till the model is get trained. And this also solved the privacy in some extent because the user don't need to share the raw data with the server anymore. However, we also find out it's not safe enough because from the model update, it's easier if the attacker has the model parameter and also the model update, it's very easy to reconstruct the input data. And then there's a final solution, is a defensive privacy with filtered learning. It's prevent that the local input has very strong, the local training data has very strong impact on the model update. But the cost of this implementation will increase the number of the training round, and the utility is not so good yet. And another big challenge is if we have like deep learning network, we have a lot of parameters, and in principle, we need to add more noise to protect privacy. And then it's very hard to achieve good utility in a reasonable protection level. So then I show some examples, also technology solutions. In principle, privacy protection is very, very important for AI because without privacy protection, and we cannot gain the trust from our end user on the AI technologies. And as an organization, so the privacy need to be regulated from the management, engineering, and technology level. And the privacy-enhancing technology is a very powerful tool, and which can really reduce the risk in our business world. But unfortunately, there's still not enough real case applications of pets. So I think one reason is the product developer and the system architect is still not aware of this technology, or they don't know how to make use of this technology. But the good news is we can observe that more and more big companies already invest resources on pets. And also this year, the MIT Technology Review ranked differential privacy as one of the 10 technology breakthroughs of 2020. So I think we can really expect more real-world applications on the pets. Okay, thank you.
Questions? Okay, so I have one question. So you gave a number of examples of privacy risks of AI, but I was wondering if there's also a way to do formal verification or analysis of the risks.
So currently there are some possibilities to show the privacy risk with some experiment, but the problem is it still depends on individual AI models. So we cannot, or we cannot find yet general mechanisms to quantifying the privacy risks. And this is also a problem that if we want to choose the parameter, this epsilon in differential privacy, it's hard to link it to the real-world problem. But this is definitely the research direction we are working on.
Okay, yeah. Thank you. Time for one more question. Ahmad.
So thank you for a nice talk. What I was interested in is when you run the differential privacy on your device. Now, forget about federated learning. Have you any experience on the developer side? Is it possible to run efficiently differential privacy on the device? Because if you have in the cloud, I can understand you have a cloud farm, you can use solutions like...
The advantages of differential privacy is very fast. It's very, the algorithm itself is very simple, it's just noise addition. And it doesn't cost so much computational power. But the problem is if the model is very large and we need to add a lot of noise, but then the utility will get worse. It means that it's very hard to find...
Yeah, the accuracy gets worse, but, yeah. But in general, differential privacy, if your device is compromised, how do you protect the noise that you have to take out afterwards to understand what was your model? I mean, how do you protect the model at the same time and do the differential privacy?
So the differential privacy can only protect that the server cannot have access to the sensitive information. But if the local device is compromised, and differential privacy can do nothing.
Exactly, so that's my question. First of all, I don't think that differential privacy is going to work on devices. My critical point to differential privacy on devices, I mean, if you have many devices and you run differential privacy and you have many parameters, you run already into the problems. On the server side, I can understand you can run differential privacy because they have computational power. But maybe that's the discussion we have to have.
Yeah, maybe you should stop.
Okay.
So, by the way, so the privacy enhancing technology is a very promising field. So the industry is really looking for people in this field. So it's very nice to have a career in this field. So this is advice.
Thank you very much.